Hello everyone. Today I'm going to show you how to find the greatest common factor between numbers. So let's say that you have these two numbers and I'll explain to you what it means to find the greatest common factor. So try to remember when we're doing factors, when we're trying to list the factors of a number. So look at 18. Let's try to list the factors of 18. So what it means is to find two numbers. When you multiply it, it will give you 18. So that's what it really means. So what are the factors of 18? So what times what give me 18? Well, let's start with 1. 1 times what? 1 times 18 is 18. 2 times what? 2 times 9 is 18. 3 times what? 3 times 6 is 18. 4 times what? 4 times nothing. I mean, I know my multiplication tables, so make sure that you know them. You know it also. So 4 times nothing really gives me 18. 5 times what? 5 times nothing. Nothing that I can think of. And 6 times what? 6 times 3. You see, I'm repeating myself, so that means I can stop. So the factors of 18 are 1, 2, 3, 6, 9, and 18. What about 24? What are the factors of 24? Let's list them also. All it means again is two numbers. When you multiply it, you'll get 24. So what times what gives me 24? 1 times 24, right? What else? 2 times what? 2 times 12. If you know multiplication table again, so 2 times 12. 3 times what? 3 times 8. What else? Let's leave a little bit more room here. What else can we say? 4 times 6 gives me 24. What else? 5 times what? 5 times nothing. Nothing that I can think of. And 6 times what? 6 times 4. So you see I'm repeating myself, so I stop. So what is the greatest common factor? Again, and math, they do not choose the names for no reason, not just for the hell of it. So the greatest common has to be common and it has to be a factor. So again, what did we just do? Here we listed all the factors of 18. Here we listed all the factors of 24. What is common here? The 2 is common. The 3 is common. What else? The 6 is common. What else? Nothing else is common. But what is the greatest common factor? Isn't it the 6 that is the greatest out of all of these 3 here that I circled? Yes. So what is the GCF between these 3 guys? So it's 6. So I did that example just to show you what greatest common factor really means. But there's other ways of doing it to find it. Let's take another example. Let's say that you have numbers like 90, 168, and 420. Again, it's not that obvious to do it the same way we did the last example here. That's a little bit more complicated and harder. So I would advise you to do it that way. Again, you're going to start dividing these numbers by 2 if you can. That means you're just going to take half of it. So you're going to start dividing it by 2. Again, half of 90 is 45. Half of 168, if you don't know, go on the side and divide it. 2 into 168. How many times 2 goes into 16? It's 8 times. 8 times 2 is 16. 16 take away 16 is 0. Bring down the 8. 2 into 8 is 4. 4 times 2 is 8. 8 take away 8 is 0. So we have 84 here. 2 into 420. Again, you can divide it if you want, but I can show you tricks. If you're doing, so we're dividing it by 2, right? So 2 into 4 is what? 2. 2 into 2 is 1. Does 2 go into 0? No, 0 times. So the answer is 210. So we can do 2 again. Even this, we cannot divide it by 2 because the last number is not even. It doesn't end with a 0, a 2, a 4, a 6, or an 8. This one we can. This one we can. So this one, since we can't, we put a line here. And we're going to do 2 into 84. Again, 84. You don't literally have to divide it. You can say how many times 2 goes into 8, it's 4. How many times 2 goes into 4, it's 2. So 2 into 84 will give you 42. So what do I put here? 42. 2 into 210. This one is a little bit harder to do it that way. You can try, but you might run into some trouble. So 2 into 210. So 2 into 2 is 1. So 1 times 2 is 2. Remainder of 0. Bring down the 1. 2 into 1 is 0 times. 0 times 2 is 0. Bring down the 1. Bring down the 0 here. 2 times 2 into 10 is 5. 5 times 2 is 10. And you're going to have a remainder of 0. So the answer is 105. Can we do 2 again? Yes, we can because of that 42 here. It ends with a 2. Can we do the 45? No. We put a line. Can we do the 2? Yes. So let's do 2 and 2, 42. So 42 divided by 2. 2 and 2, 4 is 2. 2 times 2 is 4. 0, bring down the 2. 2 into 2 is 1. 1 times 2 is 2. Subtract gives you 0. So the answer here is 21. Can we do 105 with 2? No, because the last number doesn't end with a 2, or 4, a 6, or an 8, or even a 0. So we can't, so we put a line here. Can we do 2 again? 2 doesn't go into 45 because the last number. 2 doesn't go into 21 because of the last digit here again. And 2 doesn't go into 105 like we said before. So we have to move on to the next prime number, which is 3. Can we do 3 and 45? Always a trick for dividing a number by 3. All we have to do is we have to add the digits. So if I have 45 and I add the digits, 4 plus 5, I get 9, right? Since 3 goes into 9, I guarantee you that 3 will go into 45 as well. So all you have to do is go on the side and find out how many times. So 3 into 4 is 1. 1 times 3 is 3. 4 take away 3 is 1. Bring down the 5. 3 into 15 is 5. 5 times 3 is 15. 15 take away 15 is 0. So 3 into 45 is 15. And if you remember a multiplication table or your times table, 3 into 21 is 7 because 3 times 7 is 21. Now let's do 3 and 105. So 3 into 105. So 3 into 10 is 3. 3 times 3 is 9. 10 take away 9 is 1. Bring down the 5. 3 into 15 is 5. 5 times 3 is 15. 15 take away 15 is 0. So this gives us 35. Can we do 3 again? Yes, we can because of that 15 here. Let's do 3 again. 3 into 15 is 5. Again, because of your multiplication table, 3 times 5 is 15. Can we do 3 into 7? No. 3 doesn't go into 7 even. 3 into 35? No. Again, the fastest way of seeing it is by adding the digits because 3 plus 5 gives you what? 3 plus 5 gives me 8. Since 3 doesn't go into 8, I guarantee you that 3 will not go into 35. So we put a line here. So does 3 go into 5 evenly? No. Does 3 goes into 7 evenly? No. Does 3 goes into 35 evenly? No. So we cannot use 3. We have to move to the next prime number. It's not 4, because remember 4 is not a prime number, so it's 5 that we're using. So can we use 5? Yes. So 5 goes into 5, that's once. Once it's a 1, make sure that you circle it. We're done with that column. 5 into 7. 5 doesn't go into 7 evenly. 5 into 35. It's 7 times. Again, because 5 times 7 is 35. Can we use 5 again? Well, first we're done with that column, so don't even look here. So what we have left is a 7 here and a 7 there. Can we use 5 again? No. So the only next prime number we have left to use is 7. So 7 into 7 is 1. So we're done with that column here. 7 into 7 is 1. So we're done with that column here. Now, how do you find the greatest common factor? If you remember the previous videos, if we were to ask to find the least common multiple, which is the LCM, we would have to multiply all of these numbers here together. Now, we're not asked to find the LCM. We are asked to find the GCF. To find the GCF, we will not multiply all of these numbers here. We will multiply some of the numbers, but which numbers you have to multiply? All you have to do is look in here. Look at this line. In every spot, there's a number. Look at this line. There's a number in every spot. 1, 2, 3. So this line is good. Look at this line. Do we have a number in every spot? No. We don't have a number here. So this line is not good. Do we have a number in every spot here? No. This line is not good. Do we have a number in every spot here? Yes. This line is good. Do we have a number in every spot here? No. Do we have a number in every spot here? No. Do we have a number in every spot here? No, because there's nothing here. So where do we have a number in every spot? Is this line, which corresponds to that 2 here on the outside, and this line, which corresponds to that 3 on the outside. So whichever number that I just circled here, just because they had a number in every spot, these are the number that we're going to multiply to give us the GCF. So our GCF will be 2 times 3, which is 6. Let's do one last example. So let's say that you have 7, 12, and 20, and you're asked to find the GCF. So let's do it pretty much the same way. Again, we always start dividing it by 2, if we can, of course. So can we divide 7 by 2 evenly? No, 2 doesn't go into 7 evenly. 2 goes into 12 evenly. Yep, 6. So since 2 doesn't go into 7 evenly, you put a line here. So 2 goes into 12 6 times. And 2 goes into 20 10 times. Again, you can go on the side. All it means is literally divided. 2 into 2 is 1. 1 times 2 is 2. 0, bring down the 0. 2 into 0 is 0 times, because 2 is too big to go into 0. 0 times 2 is 0. 0 into 0. So 2 into 20 is 10. Now, can we use 2 again? Yes, we can. Can we do 2 and 7? No. Can we do 2 and 6? Yes, 2 goes into 6 3 times. Can we do 2 and 10? Yes, 5. Can we do 2 again? No, we cannot do 2 with 7. We cannot do 2 with 3. And we cannot do 2 with 5. So we have to move on to the next prime number, which is 3. Can we do 3 and 7? No, so we put a line. Can we do 3 and 3? Yes, gives me a 1. Can I do 3 and 5? No, because 3 doesn't go into 5 evenly. Can I use 3 again? 3 doesn't go into 7 evenly, and 3 doesn't go into 5 evenly. And this column here, we're done with it because we have a 1 and we circled it. So we have to move on to the next prime number. Again, after 3, the next prime number is not 4, because 4 is even. The next prime number is 5. So we have to write down 5 here. Can we do 5 and 7? No, because 5 doesn't go into 7 evenly. Forget about that column, we're done. Can we do 5 and 5? Yes, 5 goes into 5 once. We're done with this column here, and we're done with this column here. So we have this column left. Can we do 5 again with 7? No, 5 doesn't go into 7 evenly. We have to move on to the next prime number, which is not 6, because 6 is even. The next prime number is 7. Again, look at the video about the prime numbers, and make sure that you know what the prime numbers are. So 7, we're going to do 7. Now can we do 7 and 7? Yes, gives me 1. Again, remember that you are asked to find the GCF, not the LCM. If it was the LCM, all we have to do is multiply all of these numbers here. If it's the GCF, you go on the side here and you check which row here, which line here has a number in every spot. Here I can see that there's a spot here missing a number. This line is not good. Here, same thing. Doesn't have a number here, so no good. Here, there's no number here and there's no number there, so no good. Remember that each spot needs to have a number. Here, there's no number here, nothing we wrote here, nothing here. Nothing here, so not good. What about here? We only have a 1 here. There's no number here and there's no number there. So, not good. So it's a problem. So what does it mean? We cannot multiply any of these numbers together to find the GCF. So whenever you have a case like that, your GCF will always be 1. So in this case, there's no numbers here that we could multiply, just because, like we said, there's no, some of the spots here have no number in there. So we cannot multiply any of these here. So the GCF will be 1. So thanks for watching, and make sure you practice. Bye.